Hi guys, welcome to my YouTube channel for another video in Grasshopper. It's been a long time I've just posted videos in my YouTube channel. Right now I'm trying to post some videos as I'm working as a freelancer. As I started to work as a freelancer now, I think I have plenty of time to post. There are plenty much content in YouTube, like a lot of experts posting on Grasshopper. Just want to continue from my part as well, so I hope it is useful for you guys. Currently in this video what we are going to see is we are going to make a base, something like this. Sorry for my sketch because I'm drawing in with the mouse. Now I'm going to create a pattern in a rectangle in a surface, and I'm going to morph it in this space, and you can morph it with any other surface. Okay, so let's try to do it. First, obviously, let's create a vase with Grasshopper, which is pretty simple, to create some ideas. I took a bifocal component first, which enables you to see, it creates a label on the icon. And this is like a circle component, which allows me to draw a circle, and with a number slider I can control the radius of the component. Now what I'm going to do is, I want three different circles on three different radius. Either I can create a merge where I create like a three different number slider. Okay, and you see there's three different three different values been input is been given as a radius, so it gives you three different a list of three circles, but which I usually don't want this, so I usually take range. Let's go with 3. So as I said in my videos multiple times, that when you use a range, instead of 3 it will give you 4, because 0 to 1 is 2 number, and it will create another 2 number in between this range, in between the domain. So it includes a start and end, so you will get a 4 value. And now what I'm going to do is I'm going to create a graph mapper. So let's take a graph mapper which controls the range according to the graph we are inputting. Let's say it's a sine wave for right now, or if you want to more control, let's go with there. And then I'm going to multiply this. As you see, the value or in 0 to 1 as the domain is here. Either you can give the value, change the value here, or you can multiply the factor, or you can remap the number. There's a lot of options for the same process. So what I'm going to do is I'm just multiplying it and so you can see there's 4 values, but I want 3, so I just give you 2, and you only see in the screen there's 2 curves because of this graph. It has a 0 and it has 1, and it creates one circle in between based on the range, based on range. So what I do is I don't want the 0 here. You can see the 0s moving. So if you in your school days, if you had ever had a chance to work on graph maps which you work in the graph plotting, if I'm not wrong the name, if I'm not mentioning the name correctly, there you would have studied more about the graphs. The same concept is used. Okay, this side is 0, this side is 1. So the point determines the value based on the domain which you provide. So that's how it works. Now I'm going to move. So the same way what I did for the range, I'm going to use to move on the Z axis. And now I want a graph mapper. Obviously, let's copy here the same. I'm using the same range because move is also I need a at 3 different value, and maybe not 20, like let's give 20, or like let's give separate value, so you get something like this, if I'm not wrong. Yeah. So what I'm going to do is I'm going to bring it here. No, let's go here. Okay, now okay, I want like a vase kind of structure. Now let's loft it, which is more visible. So what I'm going to do is I'm going to change the value in a way like I want to increase the height, the range of sight, proportion. Now I'm editing based on my factor value. No, this. Okay. Let's say like I want one more. This one looks fine. And so Surface Morph. This is a component which we are going to use to morph a pattern or something on the surface. So make sure it's a surface, it's an untrimmed surface, then only it's possible to morph, or else if it's a beat up, then it's not. So you see here, how can you like, you see here, it's a one single surface because it's on one edge and it's been revolved, the same edge is revolved 360 in a way that it creates a surface. Sometimes, not in the process the way I create, but sometimes it looks like a surface, but if there are two edges, then it's a kind of a bit up where you're stretching two edges together. So you just either need to rework on the curves like in the way how you created it, or like so on that case like it won't work. So that's why I'm saying if you are using the same process of what I do, it will work because it's a simple process. But when you try to do on the surface which you already created something else, there comes a problem. So now we are going to create the geometry to morph on it. Either you can get the U and V surface dimension. Yeah, you can get a U and V and then create a rectangle. So either you can, this is like a rectangle, like an unrolled of this surface, like the same dimension, and we create this rectangle, and if you are create a pattern in this rectangle and you can morph it, which is also fine, or else you can make this as a reparameterize and create a surface, because when you reparameterize, this value becomes like not here but here, it becomes like a domain to 0 to 1. Sorry, I'll do it here. So it becomes like 0 to 1 where the U, V, W, you give the 0 1 value, which is easy to make. Right now, let it be like this. Let's start with the pattern which I'm planning to do. I don't know, maybe this is like this one I used to create a 3D printer base when I was working for a company. So I don't know if it's like people has like different so now let's create the base. So now let's create the pattern. So what I'm trying to do is like first I'm creating like a wave, then again, so and then I'm creating a loft like this, so something like that. Let's see how it works. I'm not sure. So let's say like let's say I give a value of 100 as my domain, like the number of point, and sorry, the number of domain, like the length. The number of point will be like 100 here. So let's create the expression. There is an expression actually, which you go here. This is called expression component, where I give x cos y into r. R is the rotation and 0. So the z is like 0. So technically, like what I'm doing is cos of y into x is like x is the, let's say, like the pi, the degree, like the creation, and cos y will give you, like I'm bad at explaining this, like what is it? Let me do it, and I hope you understand. I don't know, every time I'm really bad at this expression and explaining these expressions, So the same range here, I give here, and let's say like pi, and so x is here. Let's say like 10 pi. I want like 10 rotation like this, and let's say r is like the radius. You see like this part, fan, or you see here. So you can see the r is the curvature, like from the middle point to this distance is called r. You can say like a radius. And here, like you can say the number of turns, like number of pitch, like the turns of waves you want. If you see like 6, 1, 2, 3, 4, 5, 6. That, like you can see here. So the domain is like 0 to 6 pi. So a pi 0 pi 2 pi, if I'm not wrong. No. So it is like 6 pi is like the rotation, like 0 to 360, like these kind of things, So I'm just creating this way, and let's say like I just double click the number slider. You can just view the property, and you can increase the length for now. Let's say like what is the length here, if I'm not wrong? Surface dimension. Let's create a rectangle and see what it shows. Okay. Okay, let's give this as a length, and let's make sure. Let's reduce the angle. For now, the radius maybe, let's say like 0.5. And I don't want to see it as a point. Let's give an interpolate curve, so it's good to visible as a curve instead of like a number of points, so I can see the waves and everything. Okay, 10 makes sense, proportionally it looks good, like because like it's here the numbers are not like for production or anything, it's just like a visual appearance. So but when you do like a production, or like when you're doing a printing, there comes the ratio and numbers are like more should be more accurate, Now what I'm going to do is like I'm going to create a copy here, like the copy of the same curve, like a mirror, but I want to like let's say I'll just try to dot. Okay, this is the curve. Okay, and I want to mirror like this, so I need a plane here which guide me to mirror the same curve. How can I create it? Well, there's multiple way to do. The way I'm going to do is using a bounding box, which gives me a box around the object, And now I'm going to deconstruct the box, so it's typically a bit up. And now I'm going to list item, the edge. Yeah, I think usually in a rectangle I need the opposite side of it. So let's say like, let's reverse it. You can see here, and let's do the 1. So we got this curve here, which will be our reference. You can use the middle point if necessary, or else let's say like you can also use this middle point, and if not, let's make it a little simple over here. Let's say like move unit y, yeah, let's say 20. It's too much, yeah, I know, but for now let's say like I'm going to create a plane normal. So plane normal is origin will be the point which we created, and the plane is like I want a plane in the z like y axis. So when you create, like you see the black color, it identifies the normal. So when you create a vector, then there will be a plane perpendicular to the vector, if I'm not wrong, if I'm not saying it correctly. Let's say like I want a axis over y axis, unit y. So it's done. Now let's mirror it. You got it. I don't want to see the plane. Let's hide it for now. So it's technically like if you don't give it, so the arc value, wait, actually, I don't want to see the plane, I want to see the point. You can see here the arc value is 0.6 something, and by default is 1. That's why it looks like in the mirror. So you can either, if you want to be like a parametrical, you can just use the R value and multiply by 4 or 2 or 2.5 if you want a small gap in between. It looks cool. Okay. So now we have the wave, like the pattern which we want. This is the base for that pattern. Now what I'm going to do is I'm going to do the linear array. The unit y. Let's say the count is 20. What the heck is this? Nah. So what happens here is like I'm just doing linear only for this point, but I just want to do it for everything. You can either use a group component or you can merge it here. Like what you can do as a reference, you can use a bounding box, then explode it. That is the way to do it. You do an array, but or else you can manually change the value by yourself. Okay, fine. So it looks good. What do you say? Let's see the reference. Not bad. Now let's increase the value until over here. Okay, if it's little more, also it's not a problem because it's going to compress to the surface dimension. It's not a problem over here. This is just like a reference for us, like especially for me, because my computer is like how do I say, it's not super strong for computing at this moment. So I don't want to do like off scale. Like I don't want to scale. I want to do the pattern in a very big scale and scale it to a very small surface. Like morph it to a very small surface. It will morph, but it will take a huge amount of time and power. Like which I don't want to do it. So that's why I'm making sure it's in the right dimension. That's why. So now let's simplify. Okay. So now if you flatten this, what you can do, what you will get is list item, select one. Okay. Because the mirror becomes the first one here. But I want this part to be the first in the list. So what I'm going to do is I'm going to just swap the item. So if you click here, it will be the first. But the second will be like this one. Why not here is because the branch has been flattened, which I don't want like that to be like this. Okay, let's what do I do is explode tree. As there's a lot of ways to do. Now I'm doing explode because it has only two component by default. Explode tree as it can explode by two. If you want, you can increase it, but when you have like 10 trees, you can't manually do it. So which is like a waste of time. For two, it's fine at this moment. Okay, if you have two branches. What I'm going to do is I'm going to leave. Let's try. Yeah, you see here. So technically, what it does is like if you have a list of item, it weaves both the item. Like one, like let's say one, two, say one A, one B, two A, two B. When like in a merge, what happened is this list is maintained, then this list is being added in the bottom of after this list. But in a view, like what happened is like this list is taken, like one, then second object is this, then third, then this is fourth. Excuse me. So this is how the difference between using a view component changes. Okay. Now we have this something like that, but I want to create an endpoint. Let's graph this for a while. I want to do something else. Okay, endpoint. Okay. I create a line, then I create a middle point. Now let me move this unit set. Okay, and now let's create an arc based on this. I'm just simplifying because of the branch of the extra zeros over there. No, sorry, this one if I'm not wrong. Yeah, simplify D. Okay, let's not simplify because of the branch. You can see here. Okay, now you can change the value however you want. I know 10 is too much. Maybe 0.5. Let's try. Dang! So now what I can do is I can do the sweep to dang. So I'm going to be the 1, 2, and 3. 3. So the mirror component over here Let's remove the expression and let's control it manually for now. Wait, my computer is loading. That's the problem. If I do a small computation, maybe I'll stop the compute and then I'll do it again. I don't know what I did. Let's damn. Let's disable this for now. So I don't want to do it. Disable it. Damn. Okay. Damn. Let's create like a small value over here. Okay. Let's enable this. Okay. Let's increase this. Sorry, it's just a count of the value. Okay. Not too much. Damn. Just I don't know. I just fucked it up somewhere. Okay, not bad. So now you got something like this. Okay, that's cool. So what I'm going to do here is okay, but okay, now I created a curve for this part. Now you see these two curves. I want to create something like that. Now let's say like let's say like I disconnect all the same way I disconnect all here. Let me remove the graph which was created before. Here it's actually cool, but I don't want this curve. Okay, so what I'm going to do is I'm going to do curl index. Over here I say like I don't want the first value. Okay, I just need to give a value in the set integer, not in the. So you can see here the first curve has been removed, which is good for now. At the same place here, I don't want the last value because like you see I just want to create like this curve and this curve. So I just want to do what I'm going to do is I'm going to create -1. Some people are telling I'm not some people, a guy in a comment say I speak nonsense. I don't know, man. I don't care about these kind of comments. So I speak what I think when I work. you don't want to listen, I'm sorry. I'll try to make it sure like it is more understandable. I'm not sure. Okay, let's connect it here. Okay, now it's graphed. Okay, you can see the curve has been created. Now let's give to the yeah, bingo. Then it's because of the arc. I need to give like two different values over here. It's because of the arc to make sure it's like it gets an identifier value. Okay. So now let's take the Surface Morph tool where I'm going to morph these two into it. Merge. I'm going to merge this. No, I'm going to join it. Let's say like bit of join. Flatten. We got one single bit. Yeah, that's cool. Yeah, that's cool. Now I'm going to morph it into the surface, into the curve. So, but like the problem here is like you see here, it start with this. You can either create another one and you can cut it out, which I'll do later. First let's try to morph this surface over here. So now I need a reference plane bounding box, which becomes like a bounding box, like it's a union box plus I give a reference. Let's stop the compute. Let's lock it. This is the up, and the domains are like as I did a reparameterize. You just need to give the so 1 becomes like 0 to 1, like 1 height. Okay, let's see. It takes some time. Let's see whether it works. Yeah. So like technically when you do reparameterize, it will allow you, it will convert the surface into like a new surface. Yeah. Okay. Grass. Okay, let's hide everything. You can see here there is a gap. This one is because of the surface is not closed over here. What I can do is let me try. So let's say like let's disable this. Preview off. Let me preview off everything. So technically what happens here is when you rotate it, this one it goes like this and the same way. So either what you can do is like you cut this into half, the first one. Okay, let's say like a list item for now. I just remove this, flatten, and here bounding box. No, I don't do it because it becomes like an untrimmed, like it becomes like a trimmed surface. Who cares? Like for now, let's create this, and let's take the area of this box. Let's create a plane on this plane normal unit z. Okay, not z, sorry, y. Trim bit up plane the interim surface. Yeah, it's technically a surface, you know. So surface plane. That's so cool. At least for now. Okay. So what I'm going to do is I'm going to replace the list here. So I'm going to flatten this item 0. As you see, I'm just replacing the list into 0. What I'm going to do is I'm going to do the same over here, but instead of 0, it's going to be -1. The first and the last. I don't know why when I do Control Z, it goes to Rhino all the time. I hate this one. Now let's see Control C, Control V. Instead of 0 is going to be -1. Let's use a panel. So -1 is nothing but a list last number. But it doesn't work here, I think. Shit, man. It again works in the first value. What I'm going to do is, okay, I think -1 work here, if I'm not wrong. Flatten. I don't want this zigzag lines. Let's put a Y here. Okay, so it's over here, and we got the. Let's flip it. Okay. No. I want the last one of that. Okay, sorry, my bad. Okay. Okay, that's so cool. Let's flip it. What I'm going to do is I'm going to use merge 1, 2 over here. I can do it like a graph things, but right now I'm not doing it here. So there's two surface. One will be the 0. Let's say like merge again. The index value 1 is the 0, and 1 is the list length, which is the last number of the list. So I think it is x -1 because 0 is counted. So now what I'm going to do is I'm going to click the item, and yeah, we got it. Okay, so now when it rotates and join, it will join together. I think so. Let's see. I hope. This is my first time doing this, like after a long time, because as I said before, I created this for an office project for 3D printed vase. Now I just want to try direct join. Okay. So we got like a one single open bit over here. Yeah. Now let's say like there's a bit up over here, which connects both the bit up over here. Let's enable it. I hope it works, but it takes some time. Morphing is like usually it takes not some time, it takes more time because of the computing of the morph. Okay, we got it. Ta-da! Well, it's too much of curve, but it's not bad, you know. The joining is perfect. You see here, yeah, you see the line over here, the one which is like open. Not bad. Now what I do is like I create contour unit Z maybe, and the layer height is like 3 if you use a nozzle 6, like just an idea. Now let's hide this. 3 is too much. Let's use a very short nozzle of 1. Wait, yeah. Now you got the tool path to 3D print this model. Like got the tool path now. So now you just literally do the 3D printing for the vase which has been created. That's it. So with this surface morph, you can create like, okay, sorry, it got picked. You can create whatever you want. Like this is one of the option, you know, like there's multiple option like this. You can see here, like you can see here the arc is like it's not like, how to say, it's not flat. So there's a lot of ways to create it. Like there's another way to make it flat. So this is how like the morph works. So like it depends on that. What I do is like I cut the top with the plane, the bottom with the plane, and then I use the print. Like I create the contour with the cutted version. So it's up to you, like however you create it. Okay. So this is the one I want to show you through this tutorial. So we created a vase, not a vase, like just a baby vase or some name.